equations are very straightforward, just like this one is on the left. That one there. How would we do that?
We would use elimination.
Okay, so what's one of the solutions for a variable?
One of the solutions is 7.5.
Yeah, in other words, 2x equals 15, x equals 7.5. And you'll notice that both of those equations are independent of one another. They don't bear any resemblance. One is not different than the other. Well, it's different than the other, but one is not mainly a multiple of the other. Okay, that's what you want to look for. In other words, whenever you have two different equations, you're always going to have one solution, and one solution only. Now let's take a couple of other situations. Let's take this situation over here, where I say in one case x plus y equals 10, and in another case x plus y equals 11. So how would you solve that? What happens if you subtract it? One equation from the other.
You get 0 for both of the variables.
0 equals a number other than 0. What does that tell you?
No solution.
Exactly.
Or
No solution. Exactly. In other words, it is impossible for x plus y to be equal to 10, while at the same time x plus y is equal to 11. You cannot find an x and a y that satisfy both of those conditions. Okay? So whenever you have two equations that are impossible, you end up with no solution. And when you try to solve those equations, what you end up with is one number equals a different number. And it doesn't matter if it's 0. If you come up with 2 equals 3, no solution. 0 equals minus 1, no solution. 0 equals 1, no solution. All right? So that's the second kind of system of equations that you're going to run into. And then there's a third kind, this kind here. Solve this for me.
multiply the top equation by -1.
By how much?
-1. Or
You meant -2.
if you do -2, it doesn't work.
You're right. It doesn't do much. In other words, if I multiply it by -2, now what do I get when I add the two equations?
0.
0 equals 0. So, and the reason I got that is because the second equation is not any different than the first equation. It's the same thing. In other words, when I say that x plus y equals 10, and then I tell you that minus 2x minus 2y equals 20, that's not a separate equation. That's the same equation. Always remember that once I multiply one side of an equation by a number and the other side by a number, I don't change it. It's the same equation. That equation is identical to this equation. It looks slightly different, but not really, as all I've done is multiplied both sides by 2. Or negative. Hold on a moment. I meant that right there. Okay? In other words, if one equation is merely a multiple of the other equation, then you have not added any information, and you're not going to be able to solve it. In other words, if I said, here's my equation, what's the solution? How many solutions do we have to that equation?
2.
Well,
or only 1.
One. X could be 1, y could be 9, x could be minus 2, y could be 12, x could be minus 100, y could be 110. How many solutions do we have to this equation?
Not infinite.
Infinite, exactly. In other words, whenever you have one equation and 2 variables, you always have an infinite number of solutions. You cannot solve one equation and 2 variables. You have to have at least the same number of variables as you have equations. So if I give you that, there's an infinite number of solutions. And if I throw in a second equation, there's still an infinite number of solutions because I haven't given you any more information. In other words, I've given you a second equation, but it's exactly the same as the first. So I'm still going to have an infinite number of solutions. And you get an infinite number of solutions when you go to solve it, and either one of 2 things happens. You notice that equation 2 is identical to equation 1. Therefore, you know there's an infinite number of solutions. Or you notice that equation 2 contradicts equation number 1, meaning there's no solutions. In other words, this equation 2 is the same as equation 1. But if I write an equation 2 that contradicts equation 1, well, that's got to be no solution. So you have 3 possibilities when you're dealing with a system of equations. You have that, or you have 2 independent equations, which are going to give you 1 solution. You have this, where you have 2 contradicting equations, gives you no solution. And finally, you have something like this, where you looks like you have two equations, but you really only have 1 equation, so that's also going to give you an infinite number of solutions. So those are your 3 possibilities. You either have 1 solution, you have no solution, or you have an infinite number of solutions. And try to think of systems of equations in that way. Okay, you're either going to have 1 solution, no solutions, or an infinite number. So the best thing to do really is, well, what I usually do when I'm looking at problems, because you never know when they're going to slip one in, is I always check for no solution and infinite number first. In other words, if you gave me this problem here, the very first thing I see is that they're contradicting. On the left side is identical, on the right side it's not identical. That means they contradict one another. That means no solution. That's the first thing I look for. Secondly, I look to see if one of the equations is merely a multiple of the other one. And if it's a mere multiple, then I really only have 1 equation. And with 1 equation and 2 variables, you have an infinite number of solutions. And finally, if I can rule that one out and that one out, and I have something like that where 2 equations, and they're different on the left side and they're different on the right, and one is not just a multiple of the other. And this is what you're going to get 90% of the time. But in Algebra 2, they're going to go through these other two possibilities, so it's good to be prepared for them. All right, let's talk about inequalities. We've done a few inequalities. Make sure that you know how to solve that. Tell me what to write next.
Add the 5.
Not yet. When you have an inequality, and you have the inequality completely isolated like this, then you're ready to say that there's one of two things that are true. Either 2x minus 5 is equal to 9, or what? Never change what's inside the absolute value sign. So that's what that means. Okay? In other words, no matter what is in between the absolute value signs, you write the left side like that, and then you write it the same way, only you change the sign of what's on the other side of the absolute value sign. Okay? Now, why did I write them horizontally? Because now I have two equations that I have to solve vertically. So this equation gives me 2x equals 14, x equals 7, and this equation over here gives me 2x equals minus 4, which means x equals minus 2. Okay? So absolute values are a lot like quadratics. You're always going to end up with two solutions. Okay? Most important thing to remember is this step right there. And it's really easy. In other words, never change what's inside the absolute value markers. Notice that that's the same right there. That's the same. The only thing I changed was the sign of the number that it's equal to. Now, if I change this problem slightly, and I do this, well now, what's the first step?
Setting it to two different equations.
Not yet. We can only do that once we isolate that.
So subtract the 3.
Yes. So you always, in other words, you always want to isolate the absolute value before you can make that statement. Okay. So now I'm ready to say what? What's the next thing?
So the next one we pull, it would be 6, and then or 2x minus 5 equals negative 6.
All right. That's fairly straightforward. Okay. You always want to do these with, whenever you have absolute value equations, you want to isolate the absolute value, and then you want to use the or to come up with two different equations, and then you want to solve each one of them. Slightly harder. Inequalities. What does that mean?
That means the absolute value of 2x.
Read the next line to me.
Okay. 2x plus 5 is greater than 6. And 2x
or not and there is a distinction here. They mean different things, so you're always putting an or there.
Or 2x plus 5 less than 6.
Less than negative 6. In other words, always remember you have to do two things there. I not only have to switch the direction of the sign, but I have to change the plus or minus sign. So the second part of the or, whenever you have an inequality involving an absolute value, you have to do two things. It's kind of like dividing a fraction. If I divide 1/3 by 1/4, I have to do two things. I have to flip the denominator and I have to multiply. So I'm always thinking I got to do two things. Same thing with absolute value inequalities. I'll give you another one.
Alright, so it'd be negative 3x plus 2 is greater than or equal to 6, or negative 3x plus 2 is less than or equal to negative 6.
Good. Solve each one. In other words, I write it horizontally so you can solve it vertically. We're used to solving inequalities vertically. And so that's why I write them horizontally and why your teacher will do the same thing. So solve that.
Alright, so subtract the 2, so you get negative 3x greater than or equal to 4. Then divide by negative 3, and you get x is less than or equal to negative 4/3.
Very good. And then solve this one.
Alright, so subtract the 2, and you get negative 3x is less than or equal to negative 8. Then divide by 3, and you'd get x.
Divide by negative 3.
And then you'd get x is greater than or equal to negative 8 over 3.
Not if I'm dividing by negative 3.
Negative 8.
Right? Because it's negative 8 over negative 3.
Right.
Which is the same as 8 over 3. Now, let's graph that. When you graph these one variable inequalities, you don't graph them on an XY plane. You graph them on a number line. Okay, so let me find my two key points. That one's I'll call negative 4/3. And this one I'll call 8/3. So where does my graph go here?
Solid dot above each of the points and the connecting line between them.
How do I graph that part that I've circled?
You put a solid dot over negative 4/3.
Well, what does that mean on a graph? X has to be less than or equal to negative 4/3. In other words, here's how I'm going to graph it. I'm going to graph it with a solid dot because it's less than or equal. And I'm going to go in that direction with an arrow on it. That's how I graph that part of it. You see that?
Yep.
Graph the other part of it, this part over here, x is greater than or equal to 8/3, same solid dot, because it's greater than or equal. Well, it's greater than or equal, so it's like a piecewise function. It's not just the area between the 2 points. You have to follow the greater than or less than sign. And
okay.
What this means is that either x is that or x is the other. If I change this and make it an and, changes everything, but we won't get into that yet. may or may not get into that. That's a very complicated distinction. Let's get into it. Let's say our answer was the following. X is greater than or equal to minus 4/3, or X is less than or equal to 8/3. Let's suppose that's our answer. Now, how would I graph that?
You would just connect the dots.
Yeah, it's that area in there. But now change that or to an and instead of an or. Now it says X is less than 8/3 and greater than 4/3. So what's the solution? All real numbers.
Okay.
Notice the distinction between or and and. When it was or, it was only the numbers between 8/3 and minus 4/3. But the moment I say and, well, that opens up the entire all real number, because X is less than or equal to 8/3 and greater than or equal to minus 4/3. Well, that includes every number on the number line. So there is a difference. I didn't want to really confuse you with that, but that's actually the perfect example to illustrate the difference between or and and. All right. Hold on a moment. Just look here. Yeah, here's another good one. It's one other situation where equations are a little different than inequalities. What's the difference here? Or what's the solution? What's the first thing you do?
You add the 9.
So now I have that because still haven't divided by a negative number.
Right, and then square root it.
So what's the answer?
X is less than 3.
Does negative, hold on a moment. Now I'm confused. The answer is actually this. In other words, it's not just X is less than 3. Let's go back and look at your answer. Minus 10 work?
What?
Does minus 10 work? You gave me an answer that X is less than 3. Well, minus 10 is less than 3.
Yeah.
Does minus 10 work?
Yes or no?
No, it doesn't. You got 100 minus 9 is not less than 0. So something funky took place here, and what happened is that when you take the square root of both sides of an inequality, it's a lot like dividing by a negative number. In other words, you don't just get x is less than 3. Because I've taken the square root of a number, one of those, the normal solution would be x is less than or equal to plus or minus 3. But that's not even correct. Okay? What's correct is that x is less than 3 or x is greater than minus 3. So on a number line, there's 0, there's minus 3, there's 3. Our answer has to be in that area right there. Cannot be minus 10. Has to be greater than minus 3 or less than 3. In other words, I had to do a similar thing as I have to do when I'm dividing by a negative number. You cannot take the square root of both sides without, usually if this was an equation and I said x squared is equal to 9, then x would be equal to plus or minus 3. But because it's an inequality, and I have x squared is less than 9, well, when I take the square root of that, the plus side stays that, but the minus side, I have to reverse the sign. And you can see that that's the correct. As long as x is between minus 3 and 3, that is a true statement. I can't just say x is less than 3, though. So inequalities have two peculiarities to them. One, when you divide by a negative or multiply by a negative number, you have to reverse the sign. And the other is when you take the square root of both sides. One of your solutions has to have the sign in the opposite direction as the other solution. And that's really the two things, the most important things you can remember about inequalities. Those two differences. Also, just by the way, you cannot divide by a variable. If I had x squared is greater than x, I cannot divide both sides by x to get x is greater than 1. Why? The reason is because I don't know if x is positive or negative. So when I divide both sides by a variable, gosh, whenever x is negative, I'm going to have to reverse the sign. Whenever x is positive, I'm going to have to leave the direction in the same direction. So you can't divide by variables or multiply by variables. Not as long as that variable can be positive or negative. So how do I solve this? I subtract x from both sides. There's no rule about subtracting a variable. Now I factor an x out, so I get this. And then I solve this. And that's going to give me all of my solutions. And solving that we'll get to another day. You have to use the same line chart you used earlier today. But always remember that. There's three things about inequalities. Dividing by or multiplying by negatives, taking square roots of both sides, or dividing by variables that might be negative. You cannot do it. All right, good place to stop. Cole, I will talk to you again next Monday, and that'll probably be our last session before you get back in school. Once you get back in school, we'll be back.
I think we have one more session left. No, yeah, that is what will be our last session before going to school. Yeah.
Yeah, and then once you get back in school, I will want you to be giving me the stuff you're covering in school.
All right, awesome.
But I think this summer has been very helpful to you, and it'll give you a nice head start. Okay?
Awesome. Thank you very much.
All right.
Yep.
Cool. Talk to you next week.
All right. Bye-bye.